Welcome to Sigma Tech. Welcome to Further Mathematics class. From our previous topic or knowledge you have about matrix, we have solved determinant before. You have the knowledge, the idea of it. But our focus here, we want to deal with three simultaneous equations using the inverse of a matrix. Now listen to me, those of you writing JAMB, most of the times you find it difficult to handle an inverse of matrix, but though you needed the knowledge of just 2 by 2, not the 3 by 3 we're about to use. So as a result, I want to do a quick revision on 2 by 2 inverse of matrix before we proceed. But however, our objectives here are revision on inverse of 2 by 2 matrix, solving simultaneous equation with matrix inverse. A quick revision on this topic. Inverse of matrix, focusing on 2 by 2. The 3 by 3, we are going to make use of it in solving three simultaneous equations. Inverse of 2 by 2. Given that let P equals A, B, C, D, the inverse of P written P1 or P raised to power 1 implies 1 all over determinant multiplied by the matrix that has been switched. You are switching the matrix. So how are we going to do that? Look at what we are going to do. First of all, get the determinant. That determinant P, that is A, B, C, D. Determinant P equals A multiplied by D minus B multiplied by C, which will give us AD minus BC. Do you get? This is all about 2 by 2. I am using alphabet for you to know the reorder and the format to follow. But to some people, they don't like seeing alphabet. So as a result, let's still make use of number here. The number we have there, we'll have find the inverse of 3, 2, 1, 4. This is a matrix. Switching to determinant, this implies 3, 1, 2, 4. Like I said, 3 multiplied by 4, you are following this order. This times this minus 2 times 1 equals what? Determinant. So now 12 minus 2 equals who? 10. So determinant of the matrix is what? 10. But this is, however, not the inverse of this particular matrix. Now let me show you the inverse. Both the alphabetical one and the numerical one. Recall that P power 1 equals, look at what happened here now. D will take the position of A will take the position of D, then you add minus sign to B, you add minus sign to C. Look at the way it will go. D is here, A is already here, minus C, minus B. All over who? Determinant. So this is an inverse of a matrix. So in terms of number, we have 3, 2, 1, 4. This implies switching. 4, 3, minus 1, minus 2. Now, we have determinant already. Let's assume that is Q. Q power 1 equals what? This switched matrix all over who? determinant, which is 10, meaning 4 over 10 minus 1 over 10 minus 2 over 10, then 3 over 10. This is what the inverse of the matrix 2 by 2. I want you to pay attention more because we are doing the one that is more complex than this, which will enable us to solve our simultaneous equation. However, there are several steps involved in an inverse method of simultaneous equation. The first one is what we call cofactor. Once you have your cofactor, you think about the transpose. And recall that transpose of a cofactor is simply an adjoint. Now, when you get your adjoint, also get your determinant. Now, determine adjoint all over determinant will give you a particular value. Now, to decide the values of x, y, z, the final solution of an adjoint multiply by the initial matrix. Recall that ax equals y in the matrix. Okay, let me wipe here now. Recall that ax equals y. I can show you the meaning of this. Let's look at, if given this is simultaneous equation, s plus y equals 2. I want to show you the meaning of a. A means the coefficient of x and y. Yx represents the s, y, z, the alphabet. Y, there is a value for y. Look at x plus y equals 2. So y here now is representing 2. So assume that I want to transform this into matrix form. I will say A, the coefficient, this is 1, 1. Let's assume we have 2s plus y again equals 3. And I have 2 here, 1. Into who? X, meaning x and y, equals who? Y is 7, 2 and 3. You have transformed. I know I'm using 2 by 2 for now, so there will be no confusion at all. Now let's enter the main deal for the day. Solving simultaneous equation with matrix inverse. There are some steps to follow. Begin to jot them down. I will write it one after the other before I start to solve. Steps to follow. 1. Get the cofactor. The cofactor of the matrix. 2. The transpose of the matrix. 3. The adjoint of the matrix. 4. Determinant. Listen, determinant may be 1. It depends on individual. You can answer number 2, determinant of the matrix. Then recall that transpose of cofactor equals adjoint. Do you have a summary relation of what's the term transpose? In a matrix, when column becomes row and row becomes column, you call it what? An adjoint. That is the meaning of an adjoint. Meaning of transpose. Adjoint, as I said before, I said adjoint is just the transpose of what? Cofactor. Okay. There may be a little delay in our cofactor because we are going to determine each individual value. Look at it. Having taken note of this, I want to wipe it. So the matrix x plus the equation x plus y plus z equals 2. Then 2x plus minus 3y minus z equals minus 1. Then 3x plus 2y minus 4z equals minus 27. Work on this principle. Ax equals who? Y. Then inverse of y equals a multiplied by y. We'll get there. Transforming this into matrix form by getting the coefficients, meaning I want a equals 1, 2, 3, 1 minus 3, 2, 1 minus 1 minus 4. This is my A. So my x now equals x, y, z. Then my y now equals minus, 2 minus 1 minus 27. This is the way I'm listing it. I know why I am doing this, so that there will be no confusion. Those of you in going for engineering, take note of this topic. I bet you, year 2, year 3, you will still meet it. Using inverse method to solve a complex simultaneous equation. If at that point, you may get up to 4 by 4. Depends, but I pray. Okay, to proceed, I'm going to write that ax equals y is the same thing as saying this is 1, 1, 1, 2 minus 3 minus 1, 3, 2 minus 4 into x, y, z equals 2 minus 1 minus 27. The deal has begun. So this now, if I have this, it means I'll have to go to my cofactor. Remember what I told you, you can do cofactor first, or you can decide your determinant first. So now, I want to get determinant first. Determinants of this matrix: 1, 2, 3, 1 minus 3, 2, 1 minus 1, minus 4. Determinants of the matrix, this implies plus minus plus. I will have 1 into minus 3, 2, minus 1, minus 4, plus minus 1 into 2, 3, minus 1, minus 4, plus 1 into 2, 3, minus 3, and 2. This will give me 1 into 12 minus minus 2 minus 1 into minus 8 minus 3 plus 1 into 4 minus 9. This will give me 14 minus 1 into minus 5 plus 1 into 13. 14 plus 5 plus 13 will give me, this is 19. 19 plus 13, this is 12. 32. I have 32 as my determinant. As my determinant. If I have 32 as my determinant, I want to decide my cofactor. The cofactor of this matrix I still have the matrix there. This is 1, 2, 3. 1 minus 3, 2, 1 minus 1 minus 4. Cofactor. Recall our determinant, I want to keep it somewhere. Determinant equals 32. So now, for cofactor, the rule, we're going to have 1, 2, 3, 1 minus 3, 2, 1 minus 1 minus 4, plus minus plus, minus plus minus, plus minus plus. But the difference between cofactor and the other determinant is that in cofactor, these values, you are not taking them one after the other. You are just deciding the value of the multiplicand or the multiplying effect. If I want to take this place, it is obvious that I have plus. Now if I rule, what do I have here now? I will have minus 3, 2, minus 1, minus 4. So it is important I label A11, A12, A13, A21, A22, A23, A31, A32, A33. When I have this, A11 equals this way. Let's plus into 2, 3, minus 3, and 2. What sign is here? Minus 2, plus. Okay, not taking this. I'm taking minus 3, 2, minus 1, minus 4, plus, minus, plus, minus, plus, minus, then plus, minus, plus. plus into, this is minus 3, 1, minus 2, minus 4. I want to decide it. This is plus into this and this, 12, minus 2. This will give me plus, that's 14. I have A11 as 14. Now, A12 equals plus minus plus minus plus minus plus minus plus. A12, this place and this place, here and here. I'll be having 2, 3, then minus 1, minus 4. Plus minus plus minus plus minus plus minus plus minus plus minus. Then plus minus plus. This will give us, what sign is here is minus sign. 2 times 4 plus 3. This is 8, 11 minus 11. This will give us 11. Okay. A11, 14. A12 minus 11. A13. Let's solve for A13. Let me remove these signs. To avoid confusion. A13 equals plus into 2, 3, minus 3, 2. Plus minus plus minus plus minus plus minus. We're going to have plus, this is 4, plus 9, 13. A13 is 13. Then A21. Let's decide A21. A11, A12, A13, A21 implies this way, that is 1, 2, 1 minus 4, plus minus plus minus plus, like this, plus minus plus minus plus minus minus plus minus. Plus minus plus minus plus minus plus minus plus. This will give me minus 4 minus 2. Okay, minus, that's plus 2. 821 equals 6. Eight two two equals 822. This way, 1, 3, 1 minus 4. Okay. Plus, minus, plus, minus, plus, minus, minus, plus, plus, minus, plus, plus, minus, plus, minus, then plus, minus, plus. This will give us minus 4 minus 3. 822 equals minus 7. Minus 7. Then A23 this is 823. This way to remain 1312. Plus minus plus minus plus minus. Plus minus minus plus minus plus minus minus 2 plus 3 to give us minus into 1 plus minus 1. 823 equals minus 1. This is the value of 823. Let's go over to 831. 831 equals, look at 831 here. You rule out this place, you cancel here, what will remain? 1 minus 3, 1 minus 1. Then you go back again. The person you are deciding, or the number you are deciding, what is the sign? Plus, minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, minus. So this is changing to this. Then plus, minus, plus. We will have minus 1 plus 3 to give us 2. So 831 equals 2. 831 equals 2. Another thing here, we decide for A32. A32 implies this is A32. This way and this way. This is 1, 2, 1 minus 1 plus minus plus minus plus minus. This is becoming this. Plus minus plus minus plus minus plus minus plus. So this will give us minus 1 plus 2 equals minus 3. A32 equals minus 3. A32 is minus 3. Now let's determine for A33. A33 this way and this way. What will remain? 1, 2, 1 minus 3. We still decide the sign that will be assigned to this place plus A33 plus minus plus, then minus plus minus plus minus plus. A33 is minus 1. A33 equals minus 1. So let us bring down the matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. This will give us the new matrix this way. A11, 14, A12, minus 11, A13, 13, A21, 6, A22, minus 7, A23, minus 1, A31, 2, A32, minus 3, minus 1. Now the next step is to get the transpose of the cofactor, that is CT equals this becoming this way, row becoming column, 14 minus 11, 13, 6 minus 7 minus 1, 2 minus 3 minus 1. So transpose CT equals adjoint. So this is our adjoint. Now we have adjoint. We have determinants already. If we have our determinant, we are very close to the final solution. So what will happen now? Let's use this space by saying Adjoint all over determinant equals inverse. Adjoint divided by determinant equals inverse of matrix. So what's our adjoint? Adjoint, this is this 13, 6 minus 7, 1. This is 2 minus 3 minus 1. One over 32 equals inverse. This is our inverse. Now to decide our solution, recall that we are looking for the values of x and y. Which one represents our x and y? 2 minus 1. That's the value of y, 2 minus 1 and minus 27. So I want to decide it here now. That is 14 minus 11, 13, 6 minus 7 minus 1, 2 minus 3 minus 1 into x, y, z equals 2 minus 1 minus 27. Then 1 over 32. Now to get the value of x, to solve for x equals 14 times 2, 28, minus 6 times 1, minus 6, 2 times this, minus 54. X equals this minus this, that's 22. 54, 22 is 32. So x now is 1 over 32 multiplied by 32. That's minus 32. X equals minus 32 all over 32. X equals minus 1. So that's the first solution for x. We need to solve for y. Recall, this is x, y, z. To solve for y now, I will have that minus 11 times 2, y equals minus 22 plus 7 plus, this is 21 carry 2, 6, 71. Let me verify. It should be 81. This is 21 carry 2, this is 6, 81, okay? So y equals 88 minus 22. Y equals 66, okay? So now y implies the determinant multiplied by 66. Y equals 33 all over 16. Anything wrong with y? So y is bringing a fractional value. (11) minus 22 plus 7 plus 81. Okay, I will trace where the value is trying to create this. Otherwise, it should be a whole number. But let's check for Z. 32. 96. Z. 26. 1. 27. 54. 27, 27, 54, 32, 27, 16. I think from, let's check this column for our cofactor. If I replace this, this is 14 minus 11, then 13. That is, I want to cross-check A12 and A13. See our simultaneous equation: 1, 1, 1, 2 minus 3 minus 1, then 3, 2 minus 4. A11, A12, A13. Plus, minus, plus, minus, plus, minus, plus, minus, plus. A12 minus 2 1 3 minus 4. This is minus 8 minus 3 minus, this is 5, so minus 5. Okay, it's not minus 11. I've traced that one. That's minus 5. Check for A13. 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 This way, minus 2 minus 3, 3 minus 4. This is plus, okay? 8 plus 9 equals 17, not 13. Okay, let's cross-check this 821 if this is another. 821, that's here. This way, minus 1, minus 2, minus 1, minus 2, 1, minus 4. Minus is there. 4 plus 2. Minus 6. Minus 6. Then A22. A22 this way, 823. 823. This way, this way. 1 minus 1. 3 minus 2. There's a minus sign there. Minus 2 plus 3 equals 1. Then minus 1. Okay, it's another 822. 822 this way and this way. This way, this way. 1, 1. Then 3 minus 4. This is plus minus 4 minus 3 equals minus 7. It's not okay. So plus minus 7 minus 1 minus 3 minus 1 2. Okay. Four times 14 times 2, 28 plus 6 minus 54. This is 24. 30. Solve for y. Let me check y. Minus 10 plus 7 plus 81. This is 71, 78, 32. 2 here, 39, 2 here, 16. So you can actually see that a proper care needs to be taken during the multiplication of cofactor. The final solution is not where the problem is. It's the arrangement of the initial solution. Ladies and gentlemen, once again, I want to thank you for take your time to break it down little by little. Don't be in a haste because indeed it's a complex one. There is no argument about it. Thank you. See you in the next video.